Hi, my name is Mike Thomason. We're going to be looking at a lesson on the fundamentals of electrical theory. I apologize in advance. I had some trouble getting the lighting to work out just right with the classroom lights and the projector. The webcam dims down. It's kind of dark in the background, but I'm not going to step out on you. Promise I'll be here with you through the duration, so let's get started. Now, fundamentally, we could ask the question, what is electricity? And that can be stated as simply as the flow of electrons. But what do we use electricity for? Well, we can look around our modern world we enjoy today, and there are lots of examples of how electricity has impacted our lives and our society as a whole. But primarily, we use electricity to do two things: the production of heat and the production of a magnetic field. Now, to understand the flow of electrons, we have to look a little closer at the atom. Now, all matter in the universe is made up of atoms. And atoms are made up of three elementary particles: the proton, the neutron, and the electron. Now, protons and neutrons reside in what we call the nucleus, at the center of the atom. And the electrons are said to orbit the nucleus in a similar manner. An analogy that's been used over the years is our solar system. Just as the sun sits at the center of our solar system and the planets orbit around that sun and have some orbits that are close to the sun and some that are further away, it helps to internalize the idea of something that we could never see with our naked eye. The atoms are so small, they're smaller than light waves, impossible for the human eye to see. Now, having said that, that's not exactly how atoms work, but it's a good tool to, like I say, to understand the fundamentals, especially as you're being introduced to the idea. Now, protons, we say they have a positive charge. Electrons have a negative charge, equal charge, but opposite. And neutrons have no net charge. So the protons in the nucleus are positive, the neutrons in the nucleus are neutral, and the electrons are negative. And particles with a like charge have a tendency to repel each other. Particles with opposite charges attract. We've all heard the phrase opposites attract. Well, partially where that came from. Similar to bar magnets, anybody that's played with magnets knows that if you try and put together two north poles of a magnet, they're going to repel each other. Likewise, you flip it around and try and put together the south poles, they repel. But if you line up a north pole with a south pole, you get an attraction. These particles behave similarly. Now, when it comes to matter, the number of protons in the nucleus determine what that element is. And that number of protons is almost impossible to change. You could say that it is impossible to change, but we learned back in the 40s with the atomic bomb, that nucleus can be changed. It can be split. Now, the protons are very static. If you change the number of protons, you change what that element is. Electrons, on the other hand, are more versatile. Electrons can jump from one atom to another. So we can say they have a tendency to flow. Now, like I said, the number of protons determine the element. For example, copper has 29 protons. That's what makes copper copper. If you change that number, it's not copper anymore. It's something else. Now, 29 protons that have a positive charge, copper will also have 29 electrons, the equal but opposite charge. When an atom is balanced with the equal number of protons and neutrons, they cancel each other out. We say that atom is balanced. and overall it has 0 net charge. However, not all atoms remain balanced in that way. If an atom loses an electron to another atom, it becomes positive because it has more positive protons than it has negative electrons. Likewise, if an atom gains an extra electron, we say it has a negative charge because it has an overall net more negative electrons than positive protons. Now, if an atom loses or gains an electron, we call that an ion. If it has gained an electron, we call it a negative ion. If it has lost an electron, we say it's a positive ion. And for example here, you can see we have an atom with 2 protons. Now that would be helium. And if it was balanced, it would have 2 electrons. This is an example of a negative ion. As you can see, it has stolen or borrowed an electron from another atom. More electrons than protons, negative ion. Here's an example with the same atom of helium that has lost that electron. Now it has a positive net charge because it has 2 protons and 1 electron. That's a positive ion. Now the electron's orbit, or the shell, can only hold a specific number of electrons. And the first shell closest to the nucleus can only hold 2 electrons. Consecutively after that, as we add electrons to the atom, the consequent shells can hold up to 8 electrons. We call that the octet rule. So as the number of electrons increase, the shells get filled, 2 in the first one, and then 8, and so on as we add electrons. Now, regardless of how many electrons an atom has, the only thing that really matters is the number of electrons in its outermost shell, or its outermost orbit. We refer to that outermost shell as the valence shell. And hence the electrons that are in that shell, we refer to those as the valence electrons. Now, materials that conduct electricity well are known as conductors. And they actually have 3 or less electrons in its valence shell. Materials that conduct electricity not so well are called insulators. And they have 5 or more electrons in the valence shell. Now that leaves us with a happy medium in there with 4. Materials that have 4 valence electrons, we refer to those as semiconductors. An example of a conductor would be copper. Now copper has 29 protons, and if you count all these electrons, there are 29. And as you can see, as those shells filled up, that 29th electron is in a shell all by itself. So that valence shell has 1 electron. An example of an insulator, argon. Now as you can see, argon has 1, 2, 3, 4, 5, 6, 7 electrons in its valence shell. That makes it a very good insulator. And an example of a semiconductor, silicon, carbon, tin are also semiconductors, have 4 valence electrons. 1, 2, 3, 4. Now, as electrons flow from a concentration of high electrons to a concentration of low number of electrons, we can visualize that transition being a flow of electrons. Now, as electrons flow through a conductor, heat's generated. That's one way we use electricity to do work. And it's generated from the actual friction of the particles bumping into each other. So the more electricity we have, the more heat we can generate. Now also, electrons flow, they create a magnetic field around that conductor. That's the other way that we use electricity to do work. when all the electrons are lined up, pointing in one direction and flowing in one direction, it creates a magnetic field around that conductor. We can use electrons to flow by creating an electrical force. We can cause them to flow. Electrons don't just flow because they want to. We have to encourage them to flow with some type of force or some type of pressure. Now, the force that we use to cause electrons to flow, that force or that pressure, we call voltage. This force causes the electrons to flow in the same direction, so they jump from atom to atom. Now, the actual flow of the electrons, we call that amperage. And since electrons don't have a tendency to flow automatically, it does take a force to overcome their desire to sit still. That force, voltage, has to overcome the resistance to the electrons wanting to sit still. Now, there's 4 factors that determine the level of resistance in a substance. The type of substance, of course, determines if it's a conductor or an insulator. But then the length of the conductor, the longer the wire is, the more resistance it will have. The larger the diameter of the conductor, the less resistance it will have. And resistance also varies with temperature. Most elements, as the temperature increases, so does the resistance to electrical flow. Now, the resistance we measure in units called ohms. So that gives us our 3 units of measure that we use to calculate a circuit's behavior. We get this from Ohm's law. And you can actually think of electricity flowing. You can use the water hose analogy. Think of a water hose hooked up to a faucet with a hose connected and a valve on the end. If you have water flowing through that hose, it takes water pressure to make it flow. And just like electrical flow, the flow of electrons, we have to have pressure to encourage them to flow. Our water pressure is analogous to voltage. And if you think about the water hose, the water flowing through the hose, the actual water is similar to amperage. And the resistance, which is the material's characteristic to resist the flow of electrons, the resistance would be similar to the hose itself. You can think of a large hose like a fire hose hooked up to a fire hydrant. It's going to flow a lot of water. But a smaller diameter hose, such as a garden hose, is going to flow less in comparison. And we use Ohm's law to calculate and predict what goes on in an electrical circuit. There are lots of mathematical equations, and I could fill this board up with them, but there's a simple method that is easy to comprehend, commit to memory, and very valuable. Ohm's law states that it takes 1 volt of pressure to push 1 amp of current through 1 ohm of resistance. So there is a 1 to 1 to 1 ratio with these 3 units of measure. And we have what we call a solving circle. Instead of trying to memorize a lot of equations like amperage equals voltage divided by resistance, or voltage equals amperage times resistance, or resistance equals voltage divided by amperage, and so on, we use the solving circle. And if we know any 2 values, we can calculate the third using the circle. For example, we have a circuit here with a battery, a conductor. We have a 4 ohm load, has 4 ohms of resistance, and a circuit back to our load. We know the voltage is 12 volts, and we know the resistance is 4 ohms. So if we put 12 in our voltage area and 4 in our resistance area, that tells us we need to divide 12 by 4. So we don't know the amperage, but we know the voltage and the resistance, this can be calculated. So 12 divided by 3 is 4. I'm sorry, 12 divided by 4 is 3. So in this circuit with 12 volts and 4 ohms, we would have 3 amps. Here's a couple of other examples. If we don't know the voltage, but we do know the resistance and we know the amperage, we multiply those two. So 4 times 6 is what? That would be 24 volts. Another example here where we're trying to calculate the amperage. We have 12 volts, we have 3 ohms, divide 12 by 3, that would give us 4 amps. Okay, so in summary, we talked about atoms containing negatively charged electrons and positively charged protons. And remember, the protons are in the nucleus, and the electrons orbit, we say, the nucleus. Atoms with excessive amount of electrons are negatively charged, and we call that a negative ion. Atoms that have a deficiency of electrons are positively charged, and we say that's a positive ion. And remember, electrons can move from one atom to another if there is electrical force, electrical pressure to encourage them to do so. Many materials with free electrons are good conductors. Copper is the most common conductor. Insulators are materials that do not conduct electricity easily. And a semiconductor refers to a material that conducts electricity more easily than an insulator, but not as well as a conductor. And free electrons require a pathway or a circuit and require a force acting upon them, such as a battery. We also talked about charges. Like charges repel each other, and unlike charges attract each other. It's the attraction of the free electrons that creates a force, and that force we call voltage. We talked about the 4 factors that determine the electrical resistance of any type of material, being the length of the conductor, the size or diameter of the conductor, and the temperature of that conductor. And electrical resistance refers to the degree at which a material opposes the flow of electrons. And resistance is measured in ohms and is constant unless temperature changes. Okay, short and sweet, but I did use Screenocast to produce this video. I'm still new with the technology, but I hope to get a little better with it. Thanks for your time, and adios.